So organics for this year, carbon has 4 available bonds. That's what you need to know, and you need to understand that. And obviously hydrogen will have 1 available bond, so it would easily attach itself to the carbon bonds there. So that's just showing it to you guys in terms of a Cooper structure. If you wanted to draw the Lewis structure, it would be like this. And then the hydrogen would have 1 available electron that is available for bonding. And then there we go as well. Okay, so that there is essentially showing us why carbon has 4 bonds, why carbon has those 4 bonds there, by Cooper and then by Lewis. Now for grade 12, you would typically just need to draw it in this form here, this first form. So let's first get into the important part of understanding how you name a particular organic compound. So you're going to first understand and learn these things. First, math is going to be for 1 carbon, eth is going to be for 2, prop is going to be for 3, bute is going to be for 4, pent is for 5, and then we're going to do hex, which is for 6, hept is for 7, oct, and then that's essentially where I'll stop for now, right? And then we'll do the remaining 2, because I don't think it's that important, especially not for now. We'll do the remaining 2 in our classes, right? Okay, so those are just telling us basically our prefixes for our carbons. So for example, if we're dealing with something that had, let's say methane, this here would be methane. Ethane would be this, 1, 2. Now, eth basically tells us that there is, let me use a different color. Let's do that. Eth basically tells us that there's going to be 2 carbons, 1, 2. So 2 carbons attached to each other. And then 1, 2, 3, 1, 2, 3. But essentially it's 4 in total. So if we have a look here, 1, 2, 3, 4. 1, 2, 3, 4. So there's 4 bonds still. So that's what you need to keep in mind, that carbon needs to have 4 bonds. And once you know that, you should be fine. All right, so now what we're going to do is we're just going to attach our hydrogens just for the fundamental and easy parts of this. So that is telling us that we have 2 carbons and then we have all single bonds between our carbons. So you'll see here that there is a single bond between the carbons. If there's a single bond between the carbons, what we can then say is, if it's single bond, it's going to end in ANE. So for example, this name of this compound is going to be regarded as ethane. There we go, ethane. Pretty simple and easy. Now let's take this a step further. Let's say we had 4. So 4 carbons attached to each other. It would be 1, 2, 3, 4. You need to make sure that you have 4 available bonds on each carbon. And then there's the hydrogens, there's the hydrogens, there's the hydrogens, and so onwards. There we go. Done. Now again, important to see that we have 4 carbons directly attached to each other, which would then entail that we should be dealing with a 4 carbon main chain, so bute. And then all we do from here is we say this. There is definitely single bonds only between these carbons. We'll get to the double bonds later on in our actual first class, but for now, just the single bonds. So single bonds here, what we're going to say is the following. So if it's a single bond, what do we know? It must end in ANE, yeah? Like we said previously. So what we're dealing with here is actually butane. Done. Simple and easy. So I would suggest you just draw out all of them and you figure it out. I shouldn't say it's figured out, but if you draw out all of them, all of the different size of our carbons, not size of carbon, size of our organic compounds. So if you go propane, pentane for 5, hexane for 6, heptane for 7, octane for 8, you draw it out, it'll be easier to see. What I also want to just get into now quickly is how they can confuse you slightly with just the shape of it. But now remember, you need to always look at continuous chain length. So for example, let's take heptane, for example, right? Actually, you know what? Let's do pentane. Okay, so pentane, if I do this, carbon, 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 carbon. What you want to notice here is that it's one continuous flowing chain, right? There's no going back or anything of nonsense. So there's no, essentially what I'm saying, there's nothing like this here. There's no this, 1, 2, 3, 4, and then for example here. So here, this is not a continuous chain, right? Because you essentially had to go back or you had to go up and come back. So it's not a continuous chain. Because it's not a continuous chain, this one here, for now, we are not going to worry about it. For now, we're not going to worry about this one here because it's not a continuous chain. For the first part, we're going to deal with these continuous chains. We'll deal with the non-continuous chains, like I said, in the actual class. All right, so anyway, let's go and attach our 4 bonds to each of these carbons. So here, this is also pentane. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now, whether I draw pentane like that there, in this weird shape that I've done, or if I draw it like this here, 1, 2, 3, 4, 5. And if I just fill in the hydrogens from here, you'll see that even though it looks slightly odd, all that has happened is that it was bent slightly. The actual organic compound was bent into this particular shape. So they took this one and they just kind of bent it into this here, but it's still the exact same thing. So what you want to see is the following. If you want to count the number of hydrogens and carbons, so here we obviously have 5 carbons. And the number of hydrogens you'll see is 12. And if you do the same, if you count the number of carbons here, you'll see that it's going to be 5 carbons and 12 hydrogens. So it's essentially the same thing because what I said earlier was it's one continuous chain. It's one continuous chain. Therefore, they're essentially the exact same thing. Right, so getting into grips with the continuous chain as well as getting into grips with knowing 1, 2, 3, 4, 5, 6, 7, 8. You don't really need to know more than that. If you do, 9 is non and 10 is dec. Obviously, that's just obvious. Non is 9, dec is 10, and that's essentially it from there. Please make sure you understand this stuff before we get to that first lesson, right? Just to understand, most importantly, how the number of carbons relate to the actual prefix of the name. So the meth, eth, prop, but, pent, hex, hept, oct, and then understanding the one continuous chain thing is very important, like we've explained here, the one continuous chain thing. All right, I guess I'll see you guys in the lesson next week, yeah?